Radhe Govind, my dear students. In the last class, we discussed about the classful IPv4 addressing, in which we studied that class A IP addresses has 24 bits for the host IP addresses and 8 bits for the network ID addresses, in which the most significant bit is set to 0. So the network addresses may range from 1.0.0.0 to 127.255.255.255, in which the addresses starts from 127.0.0.0 to 127.255.255.255 are used for loopback IP addresses, which are used for the host itself. And when we talk about the host IP addresses, they can use 24 bits. So total addresses for the host are 2 raised to power 24 that can be used for the host IP addresses, but all zeros and all ones we cannot use. All zeros denotes the network address and all ones denotes the broadcast address. So the class A host IP addresses can be 2 raised to power 24 minus 2. That is, you can see that when you calculate them, they are about 2 raised to 24 means 16777,216 minus 2, it is 16777,214. So this is about class A IP addresses. Now the same thing is for class B addresses. It can have 16 bit for the host IP addresses. That means 2 raised to power 16 addresses minus 2 addresses can be used for the host IPs, and first 2 octets having 2 bits set for most significant bit set for 1 and 0, it can be used for the network IP addresses. So since you have taken in the most significant octet, most significant 2 bits of the first octet has been set to 1 0, and other bits are 0 in the first octet, then it will give you the number 128 in the decimal, and all other bits are set to 1, then it will give you the decimal number that is 255 minus 64, since the 7th bit is set to 0, which is 2 raised to power 6, that is 64. So this 64 will be subtracted from 255, which will give you 191 as a decimal number. Okay, so the network addresses or IP addresses starting from in the first octet, if they have the values from 128 to 191, then these belongs to class B addresses, and if the network addresses or IP addresses starts from 192 to 223, these belongs to class C addresses, in which 8 bits can be used only for the host. That means 2 raised to 8 minus 2 host IP addresses can be allocated. That means 254 IP addresses can be allocated at most in class C addressing scheme. In class D, it is for multicast group IP addresses, and if the addresses starts from in the first octet, if the values are 224 to 239, then these belongs to class D addresses. And if the addresses starts from in the first octet, decimal values are 240 to 255, then they belongs to class E addresses, which are reserved for the future use and experimental purposes. So now I will tell you what are the network mask or subnet mask. So for class A, the network mask is 255.0.0.0. That means in the first octet, all binary bits are 1. In class B, in the first 2 octets, all bits are set to 1. And in the class C, all bits are first 3 octet, all bits are set to 1. So a network mask help you to know which portion of address identifies the network and which portion of the address identify the code. So without giving you or specifying that the this IP address is of class A or B or C, if someone have given you the IP address and network mask, then you can find out the class of that address. That means if you are given the IP address 8.20.15.1, then using this you can simply find out that this is the class A address, because the first octet decimal values are in the range from 1 to 127. So 8 belongs to this domain, so these are the class A IP addresses. Okay, now if you want to find out that what is the network IP addresses for this host IP, then you need subnet mask. So if the subnet mask is given 255.0.0.0, then put these decimal values in the binary values. Okay, and these two binary values of the addresses. If by ending these two values, you will get the network ID of the network. So here you can see that the network ID is 0001000, and all 3 octets have all the values 0 when we end with it, the host IP and network mask. So the network ID is 8.0.0.0, and for which the host ID is 8.20.15.1. This host ID is connected to the network ID 8.0.0.0 in the decimal values. So now we will understand what about the subnetting and supernetting. So subnetting is nothing but the network within the network, or when you create, you can say, class in the class A networks, if you create some other network within those network possible in, with the class A network IDs. Okay, so these are the subnets, and when you make a complete network by using some smaller networks, then it is called supernetting. Okay, so subnetting allows you to create multiple logical network that exists within a single class A, B or C network. However, you can skip these classful naming, and if you do not subnet, you are only able to use one network from your class A, B or C, which is unrealistic actually. You will always want to make the sub networks. Okay, so each data link or network must have a unique network ID, with every node on that link being a member of the same network. If you break a major network into a smaller subnetwork, it allows you to create a network of interconnecting subnetwork. Each data link on this network would then have a unique network subnetwork ID. Any device or gateway that connects an network or subnetwork has n distinct IP addresses, one for each network or subnetwork that it interconnects. So, in order to subnet a network, extend the natural mask with uh, one or more bits taking or borrowed from the host ID portion of the address. Okay, so given a class C network of 204.17.5.0, which has a natural mask of 255.255.255.0, you can create subnet in this manner. So 204.17.5.0 has if you take 3 bits from the host IDs, then you can create maximum 2 raised to 3, that is 8 subnetworks, but all zeros will give you the network address itself, which are creating the subnetwork, and all ones give you the broadcast ID in that network. So you can have 6 subnetworks using this mechanism. Each will have 30 hosts, because you can use 8 minus 3, that is 5 bits for the IP addresses, that is 2 raised to power 5, and you will subtract 2 IDs for the network device itself, and the broadcast ID. So functionally you will have only 30 host IP addresses for this subnetwork. So this is for today. Stay home and stay safe. All the best for you. And next we will discuss how this kind of subnetworking can be used for classless inter-domain routing addressing mechanism, in which we will not use the class ABC. Instead, we will use the host IP addresses prefix and length of the bits for the subnetwork IDs. Okay, so we will discuss it in the next class. All the best. Stay home and stay healthy.